Okay, now that you definitely know what a function is, you do know what a function is now, right? Here are a couple more concepts to help solidify the idea of what a function is doing. There's the idea of the independent variable and the dependent variable of a function. Input, output, independent variable, dependent variable, domain, range. Those are all linked together. So instead of trying to think about three different pairs of things, try to figure out which one they go into. The beginning section and the ending section. When we are looking at any function, and this is true for all functions, when we have a coordinate point, x, comma, y, this ordered pair it's called an ordered pair because it's a pair of numbers and there's an order to them. This is the first one, and then this is the second one. This is the input, this is the output. By the definition of a function, for each input, there is only one output. So, given that definition, we can infer that the y-coordinates value is dependent on the x-coordinates value. X is the independent variable because it can be whatever it wants to be. It's independent. It is a strong person who don't need no man. The y-coordinate is dependent on x. Y doesn't really know how to take care of itself. It doesn't really know what it is without first knowing what the x is. So there's all different types of functions, and you're going to learn all of them by the time you get to Algebra 2 and pre-calculus. To make sure that you are solidified with the idea of a function, we're going to start with the easiest type of function, which is a linear function. A linear function is just a straight line when you draw it. No curves, no dips, it doesn't halt in any way, it goes on forever in both directions. There's no sharp points, it's just a straight line. That's it. It's the easiest function to work with. So we know what a linear function looks like on a graph, but what does it look like algebraically? Well, I know that this is a linear function because looking at this x term here, there's nothing going on with it. There's no extra fluff going on with it except for this constant coefficient of 2. There's no exponents. There's no fractions involving the x. It's just x to the first power. Like if I had an exponent right here, like 2x squared, this would be a quadratic function, quadratic equation. I'm just looking for regular old x. Constant coefficients are fine. What's fantastic about functions is that only the coordinate points that are on any function are specifically the only values for x and y that make its equation true. So given that, if I wanted to know for -1, is this point on this line? Well, we could look at the graph and check it, but you can also do it algebraically. So it's always, always, always for coordinate points x, comma, y. So we plug in 4 for x. We will plug in -1 for y. We'll simplify, and if it's the true statement, then that point is on that line. So -1 equals 2 parentheses 4 plus 3. Does -1 equal 11? No, surely not. So that just means that this coordinate point does not lie on the graph of this function. And you can go about it the other way. Like if you had one of the coordinate values and you wanted to know the full ordered pair and it's on the function, you'll be asked this. I know this is kind of boring, but this is a question that you're gonna want to know how to do. So let's say I was given the point 4, and then I don't know what the y coordinate is. Put D here for I don't know what the y coordinate is. That's pretty simple. Again, just plug in 4 for x, simplify, and then whatever y is equal to, that's the y coordinate of that ordered pair. So we know now, well, we kind of already did, but we can say with confidence that 4, 11 is on this line.